Good morning, functions. We are starting a new unit. So we're going to do an introduction to functions. We're going to talk about domain and range, independent variable, dependent variable, things of that nature. So we're going to go ahead and get into that. So, all right, so we're going to distinguish between independent and dependent. Now, this is something that I skipped last year, but I want to cover really quickly this year just to make sure that we're all using the same language and we're all starting at the same spot. So we often describe one quantity in terms of another. So the amount of your paycheck the amount of your paycheck, if you are paid hourly, depends on the number of hours you worked, right? So if you work 17 hours one week and 27 hours the next week, the following week you would get paid more. So another one would be the cost at a gas station depends on the number of gallons of gas you pumped into your car. The distance traveled by a car moving at a constant speed depends on the time traveled. So here's what I would like you to write down. If the value of the variable y depends on the value of the variable x, then y is the dependent variable and x is the independent variable. So that last sentence, this one right here, this is what I would like you to write down. You may want to choose one of these examples to put on that. So go ahead and hit pause and do that. All right, so now we want to define and identify relations and functions. So again, we've already talked about our independent variable and our dependent variable. This is what it would look like if they were as a coordinate. So we want to talk about it as a point. So a relation is a set of ordered pairs. So these are an ordered pair. That is what a relation is. So go ahead and hit pause and get that down. So a function is a relation in which for each value of the first component, your x value of the ordered pair, there is exactly one value of the second component. So that means that x is unique and different, and y is unique and different. So you can have something like the function y equals x squared, where if I put in 2 for x, I get the output of 4. And if I put in -2 for x, I get the output 4. So while x is different and the y's are the same, that's okay because I have exactly one value. What you can't have is that x is equal to 4 and the answer could be -2 or 2. So if x is equal to 4, but my y's are -2 or 2, then that would not be okay, because it would say that there would be two different answers for that one. So if you didn't get this, go ahead and hit pause. All right, here is a picture of what I'm talking about. So when we talk about our x values, our domain, all possible x values would be the entirety of the domain. If we put that into our function machine, that's our new input. We have a rule, an equation typically, that is going to tell us what it's going to be, and then we get a new output, which would be that our our y value would be our range, so all possible y values, and then we would have one and only one y value. So like I said, we'll go over it. So here is another way to look at a relation. This is set notation or register notation. Notice the curly brackets. This is something that makes it different. You do need to have the curly brackets. They're not a squared bracket. They're not a parenthesis. They are a curly bracket. If you're looking on your computer, it would be the one above the enter key to directly on the left side. There's two of them. So curly brackets are different. And actually, if you're looking at the key on your keyboard, they're above the squared brackets. So when we're looking at this, if I were to draw this out, we have the same x value is paired with two different y values. So if I were to ask you -1 output, you would have to say 2 or 3. So because I'm having two different answers, two different y outputs for x, that means it is no longer a function. So in a function, no two ordered pairs can have the same first component, x value, and different y components. So that's what you want to make sure you're looking for. So if we're looking at B, notice that 5, 4, 6, 4, and 7, 4. So we have 4 being repeated as the second component over and over and over again. So it's not a different second component. But this says yes, because each different x value is paired with a y value. And this does not violate the definition of a function. So if I were thinking of the graph, so this unit, I typically think of it graphically. I think of the picture I want to see when I'm looking at this. And if I were looking at that, that would be a horizontal line from 5, 6, and 7 on the xy plane. And then it would be a horizontal line, meaning that every x value has its own y value, even though it's the same y value. So another way to look at this is called mapping. So we're going to look at these two maps, and I'm going to use arrows to say on this side, where's my mouse? Okay, right here, this is going to correspond to this somehow. So the first one, I'm going to say 1, its output is 2. The input of 2 on this side has an output of 5, and the input of 3 has an output of 6. So this says that for these values, these would be the outputs, meaning that this is a function. Because I could say, what is the output that goes for 2? You would say 2 is 5. So every one input has its own output, and each input is different. So now when I look at this map, I've got 1 goes to 2, 2 goes to 2, and 2 goes to 6. So if I asked you what is the output for 1, you would say 2. But if I asked you what is the output for 2, you would have to say 2 or 6, or 2 and 6. So meaning it has two different outputs, so this cannot be a function. So this is not a function. Alright, so now we're going to talk about domain and range. So domain and range, I typically have pictures of it, and when we think of domain, we're looking at where does it stop on the right, all the way on the x-axis, and where does it stop on the left, all the way on the x-axis. Wait, did I say that backwards to you guys? Let me see if we're looking at a graph all the way to the left, all the way to the right. Yep. And then range would be how far down does it go, and how far up does it go. So remember, when we talk about domain and range, we always want to put our smallest possible value first, and then our largest possible value. So domain and range. In a relation, the set of all values of the independent variable, x, is the domain. So this is when we say domain, I'm talking about all possible x values. The set of all values of the dependent variable, the y, is the range. So the range is the set of all possible y values. So go ahead and hit pause and get that in your notes. So when we look at this example, I could give you something in a table. So go ahead and hit pause and put this in your table. And we want to put whether or not this defines a function. And then we also want to put what is the domain. So the domain for this one are going to be the years. The 1999, 2000, 2001, 2002, 2003, and 2004. And then we want to put our range, which are going to be all the subscribers. So the amount of subscribers. So then, if I look at this, no 2 years no years being repeated, and no year has the same thing. So this is a function. So 1999 had its own subscribers that was different than 2000, 2001, 2002, 2003, 2004. So yes, this is a function. So make sure you get this in your notes, because I will ask you, in this unit, we'll be looking at, I think it's 5 or 6 different ways of interpreting information and answering these questions. So now here's a graph. So what would be the domain and range for this? So the domain for this would be, since it's going down, and it'll be going to the left, so we're talking about the x, it's going to go this way forever. Smallest possible value will be negative infinity. And then it's going this way forever, so the largest possible value would be positive infinity. So the arrowheads indicate that the line extends indefinitely left and right, meaning that the domain is going to be negative infinity to infinity. Again, make sure you're using parentheses, because we're saying that it does not equal that. It does not include negative infinity or infinity. It's just getting really close. Now when we talk about the range, our smallest possible value is going to be going down forever, because the arrows indicate that it will be extending indefinitely, meaning negative infinity. But then it will only go as far up as this point right here, which is 4. And again, 4 is included. This dot is filled in. And since it's included, that's when we're going to use that squared bracket. So it's going to be negative infinity to 4. That'll be the largest possible y value is 4. So you do not need to write this, but when we talk about this, we are talking about all real numbers. So the set is not going to include imaginary, so we can't have negative square roots, things of that nature. You can't have irrational numbers, you can have all kinds of ideas, but it's just saying specifically that we're not going to deal with imaginary. So we want to identify functions defined by graphs and equations. So we have learned before about the vertical line test, but if you do not remember what that means, go ahead and write down the definition, hit pause. So that means when I'm looking at these two different graphs, and we're going to look at this graph right here, which looks like it came from, looks like it came directly from our calculator. Now, our calculators end at the top of the graph. We need to know, this is one of those times where we have to be a little bit smarter than our calculator. We have to know how to interpret that information. So this means that it's going to go forever up and down. So we have to be careful with that. Just like when we put in -2 squared, we have to know we should be getting a positive output because a negative times a negative is always a positive. So this is another time where our calculator is an excellent tool, but we have to be able to know how to interpret that information and make that critical thinking that we can't have our calculator do. So if I were looking at this, I'm going to say I could put a vertical line anywhere and it is only going to cross one time, meaning that this is a function. So I put in a red line for that. Now when I look at the second graph, this circle, if I put a red line anywhere, then it looks like it crosses 2 times. So this would not be a function. So that's something that we're going to want to consider. So that vertical line test means anywhere I put my vertical line, it's only going to cross my graph 1 time. So if we use the vertical line test to determine whether this is a function, go ahead and hit pause and do that. So yes, this does pass the vertical line test, because if I look through these and I put a line here or here or here or even here, it's only crossing my graph 1 time. So now we have to decide whether each of these equations defines y as a function of x, and we need to give the domain. So the domain for this one, yes, y is always found by multiplying by the -2 and then adding 7, so each value of x corresponds to just exactly 1 value. Also, that graph would be a line. We've got y equals mx plus b right there, so I know it's going to be a line. So knowing your parent graphs in this unit is very helpful. So we'll have a day where we spend some time on that. So now this one has some rules, right? I said we can't have a negative number under a square root, which means we can't go any smaller than 0. So yes, this is a function, and the domain is going to be -∞ to infinity. All right, my light's turned off, oh well. All right, so this one, B, that I want to talk about, we said that it needs everything underneath that radical, or the square root, needs to be greater than or equal to 0. It can equal 0, because the square root of 0 is 0, and that's a valid number, but as soon as we get to -1, we're into imaginary solutions, because remember, the square root of -4 is 2i. So we want to be careful that we're not going into that imaginary plane. So we need to restrict our domain. We need to restrict that it can't go. So what we're going to do is we're going to solve all the way through. And we're going to make sure that x is always going to be greater than or equal to 6/5, because anything greater than that is going to create a 0 or a negative number. I'm sorry, anything smaller than that is going to create a negative number. So when we look at this, if I plug in any value for x, I'm going to get a unique solution, right? A unique y. So yes, this is a function, but it cannot be any smaller than 6/5, but it can go all the way to infinity. So we've got our squared bracket and we have our parenthesis. So now when we look at y to the 4th power is equal to x, no, this is not a function, because any value of x is going to get 2 different y's for that. So no, but the domain would be 0 to infinity. Again, we have an inequality here where y needs to be greater than or equal to, so we have a situation where we need to solve for that. And so no, this is also not a function, because we're going to get different answers, but it will go to -∞ to infinity. And we can never have a 0 in the denominator, because friends don't let friends divide by 0. So make sure you get this